At the start of the year on this course, I gave you 5 graphs that are graphs that I fully expect you to know. So there's a square root graph, there was the parabola, the cubic graph, and then one of the graphs that I gave you that we have to know is this graph right here, which is f of x equals 1 over x. Alright? So when I graph f of x equals 1 over x, basically what this graph stems from is the f of x equals x graph, and then I reciprocate it. So I'm going to start with that right now, and then I'll explain that a little bit better. So f of x equals x. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. We get that, right? So that graph looks like this. Okay? So that's the y equals x graph, right? So the reciprocal means that I take what? 1 over all of my y values. Agreed? Okay? So the first thing that I got to focus on when I take 1 over the y values is 1 over 0. So where this graph, this original graph crosses the x-axis, that's going to give me a value, or where it crosses, the x-axis, that's going to give me a value of 1 over 0, which is undefined. So at that point, I have a asymptote. So that's the first thing I do. Wherever it touches this line becomes the asymptote at that point. All right? The second points that are key to us are where y equals 1 and y equals negative 1. Because when I take y over 1 over 1, what do I get? 1. So that coordinate right there stays right there. And this coordinate right here stays right here. So that's where y is equal to 1 and negative 1. All right. All of these values for x right here, sorry, for y right here, are all fractions. Now I've talked about this, so I'm going to go through this real quick. 1 over a half is 2. 1 over a third is 1 over a quarter is 1 over a fifth is. Okay, so all of the y values right here are going to now go up when I take the reciprocal of them, right? And all of these y values, which are large, are all going to end up being smaller, fractions. So this graph looks like this. And what we have to also identify is a second asymptote. And that asymptote is right here. So far, so good. So there's the y equals 1 over x. Now we've done this a couple times. We've studied this a couple times. I mentioned it to you. So when I say sketch it, there's your sketch of it. That's simple. Draw your two asymptotes. Draw where it's equal to 1 and negative 1, and then draw your curves proper. Okay? Today, we're going to look at the shifts. So again, we are going back to this. So my shifts are as follows. Same thing, same rules apply in all situations here. What is my A value again? Vertical stretch, right? So what part of my graph, if I'm only graphing this key point here and this key point here, what am I going to do to find out what the new points are there? Instead of being 1 and 1, what are they going to be? Any idea? Yeah. So they'll be 1 and whatever the A value is, because you're going to multiply that value by A. Right? Okay? The B value, what does it do? Horizontal stretch by a factor of 1 over B. So I'm going to multiply this value right here by 1 over B. That'll take you to your new coordinate. What does C do to the graph? Shift or left it right. Focus on this guy. Focus on your 0 and 0 when you make your shifts. I would do that, draw out my asymptotes, where they are, and then mark off my 1s and 1s from that point. That also helps. Okay? And then my D value, again using that point up or down. So it moves my asymptotes and my whole graph, of course, up or down. Okay? Questions?
Do we have to put arrows for asymptotes or no?
No.
Okay.
Good question. Dotted lines work.
Okay.
Some places take solid. I prefer dotted because you can't tell the difference between the axes. But you do need on all your
Yeah, on everything.
sketches, yes, you do need that. That was a good question. Okay. So let's look at the first example then. First example wants you to do a table of values for y equals 4 over x. What does the 4 do to the graph? It's a vertical stretch by a factor of 4. So you would just times all your y values by 4, right? Okay, I'm not going to go through that. I think that's pretty self-explanatory. You can do that. Let's look at the next graph here. Graph y equals 3, x minus 3 plus 2. Okay, so my graph is y equals 3 over x minus 3 plus 2. Let's start by doing this again. I like this practice. We have been doing it all along since unit 1. What's my a value? 3. What's my b value? 1. My c value? 3. And my d value? 2. Okay, so my original sketch. Looks like that. Okay? So, key points, that one, and this asymptote stuff. Alright? So the first thing you do, always work with your stretches, you remember that? So, what am I going to, what coordinates are going to change? Instead of 1 here and 1, what am I going to have? 1 and 3. This one's going to be -1 and -3. So that takes care of my a value. My b value is also taken care of because it's 1. It doesn't change anything. So now what? Move right 3 and up 2. Just going to double this up because I made a mess of this. Didn't leave me enough room. Okay, so here's my axes here, right? Okay, what coordinate is my asymptotes going to be at now? Where they intersect. What is it?
3 and 2.
3 and 2. 1, 2, 3, 1, 2. Right there. Here's my asymptotes. So I've got that right there, right? Okay. 1 and 3 becomes what? I gotta move it right 3, so that takes me to. What is it? You're close. So 1 and 3 becomes, I got to move it right 3, so that makes it what? 4, and up 2 is 5. That's right. So 4 and 5 right here. Again, I don't have to be very specific on it. So that becomes 4 and 5. And then this guy, right 3 takes me to 2, and then up 2 it takes me to. So 2 and -1, which is right here, right? If I drew this a little bit better. And then, don't ever cross that, don't do that, do not do that. 2, -1. There's my 2 coordinates, and I'm done. Okay, yeah.
So if your B was negative.
My B, okay, let's just wait. We're going to get into this
Okay.
reflections right away. All right? Questions? Again, your base graph starts you. You have 3 key points. Almost every graph that we've done this year so far, except for trig. Trig, we want 5 key points. Every other one, we want 3 key points. Usually it's intercepts. Today it's where your intercepts of your intersection of your asymptotes are, and your 1 and your -1 y values. Okay? Alright, so next one is, alright, this creates a problem. So, this is brand new to you, so we are going to start in this question. We've got to do a little work on this. We have never done this before, so it's
fairly well imperative that we figure out how to do this. And it's not something that's easily explained. Right now, because I have an x on the top and an x on the bottom, it doesn't fit into my y equals a x over h, x minus h plus k, or in our case b, c, x minus c, x plus d. It doesn't fit into that equation, so I need to do my best to adjust this, change it, so that it actually does fit. So to do that, this is, like I said, something you've never seen before, so you gotta watch what happens here. My objective, though, is to somehow match the top of this up so that I can cancel the top and the bottom. So I'm going to change the top of this such that I get the same thing on the top and on the bottom. Alright? And it works like this. I want to factor something out of 4x and the next value that I put in here to get x minus 1. So I'm going to make this negative 4. Alright, just leave your pens for a second. So what I'm doing here is I'm going to put brackets around this, and when I factor a 4 out, it's going to leave me with x minus 1 so I can cancel them. You follow? So what I'm doing is I'm adding a negative 4 to this to start with. Now, if I add a negative 4, sorry, if I subtract, if I add a negative 4, I have to add a positive 4 so that I'm not actually changing the question. So I do this, plus 4, and then it's added 2. So all I've done is added a negative 4 and a plus 4. What's 4 subtract 4? 0. So I haven't really changed the question by doing it. But it's going to help me change my format. So all of this is over x minus 1 like this. So far are we following? Equals. I'm going to factor the 4 out of here. That changes this to x minus 1. And over here I have 6, and I'm also going to put in over x minus 1. Okay? So the first thing that you do is you add a value to whatever this first value is, so that you can factor whatever's in front of this out, so it cancels out with the x minus 1 on the bottom. So watch. Just like that. Okay? What am I left with then? 6 over x minus 1, add 4. Okay? What's my a value? What's my b value? C value? D value? 4. Now I can graph it. Okay? This is a new wrinkle in factoring to allow you to get into a form where you have y equals a over x minus c plus d. Okay? So this is new. Let's have a look at. Let's go to, look at question 3, A on 301. All right. So I need to add something here. So then when I factor it out, I'm going to get x minus 2. So what do I add to 2x so that when I factor it, I'm going to get x minus 2? Plus or minus? Minus. So I'm going to add a minus 4 here, which means I have to add a 4 right there. Okay? what am I gonna add to here? So that when I factor out the -3, I'm gonna end up with x plus 2 here. Can anybody figure out how I can get it quite easily?
Times them by each other.
Take that number and times it by there. Put it there. Okay? Because now when I factor it out, I cancel out. Okay? Let's try one more. I just want to make sure you have this step down. I think you can do everything. I need to have this step down. Ooh, here's a harder one. What am I going to put right there?
-28.
-28. Which means I have to add 28. Does everybody understand that?
Yeah, there's times them.
Yeah. Okay. And then factor them. This part will cancel out, and this will be left out here on the outside here.
And these are all 1 over x graphs?
Yes.
X over 1 of those?
1 over x. Yes. All right, so far. Are we okay? All right. That's the easy part. 9-2. This is the part that will be a little more difficult, and there's a lot more that's involved. So I'm going to start it today. I don't want to do all of it today. I want to do some of it tomorrow. So I'll record that for you tomorrow, but I'll give you the introduction today, because this is a biggie here. So turn to 305. Okay, so we just finished doing this. That's right. Okay. So we just finished doing this. When I have an x on top and an x on the bottom, singular, degree 1. If the numerator and denominator do not have a common factor, the function has an asymptote. The vertical asymptotes are identified by the non-permissible values of the function. For the function that can be rewritten in the form y equals a over x minus h plus k, the k parameter identifies the horizontal asymptote. Okay, so what that means is this. When I write it in this form, the non-permissible value is the equation of my vertical asymptote. Okay? Vertical is x can equal c. So far so good. The horizontal asymptote, y can equal d. In this equation here, where did my asymptote go to? Oops. Go ahead, one. Where did my asymptote go to? Right here, which was 3 and 2, right? 3 and 2. The equation of my horizontal one, y equals 2. Vertical one, x equals 3. We're all good with that, right? Okay, there's nothing to be. But what happens now? Okay, so that takes care of that. That's if you got a degree of 1 on top of a degree of 1, and no common factors. So we're going to look at 3 scenarios that happen here. Bless you. Points of discontinuity. That means at least one common factor. All right. So now, what happens if I take an equation such as this? I'm going to write it out a little bit different than they do in the book. So I've got x squared minus 2x minus 8 over x plus 2. Okay? So don't look at the book for a second. I say to you, I need you to graph this without the calculator. Whoa. I can't graph a parabola over top of a line. I don't know anything about this. So I need to simplify this so that I can make it work. So I'm going to factor the top and see if I can simplify it so that I can actually graph something. So let's simplify this. So I get x minus 4 over x plus 2 all over x plus 2. Neat, right? Okay. So now if I reduce this, what am I left with? X minus 4. Well, what is the graph of x minus 4? How do I graph y equals x minus 4? What's it going to look like?
Same as y equals x, just down 4.
Yeah, it's even simpler than that.
X equals 4.
If I told you to graph that in grade 10, what would it look like?
Would a negative more than draw a line?
It's just a line, right? Where does it go through? 1, 2, 3, 4. Down here. There is the graph of y equals. This whole thing right here is that graph right there. So you are capable of doing that. You're able to do that without. But there is one snag that we don't normally talk about, so that we have to look at it. They have what they call a point of discontinuity. All right? Because I have a fraction here, is there a value that x cannot equal? What is it? It's negative 2. That's right. X can equal negative 2. I need to show that on this graph. So what I do is, I go to where x is equal to negative 2, and I draw an open dot on it. So this graph right here, when broken down, is the graph of that line, but because it's a fraction to start with, I have to show what we call a point of discontinuity. The point of discontinuity always occurs within the values that you cancel out. That's where you find the point of discontinuity. So we are able to now reduce these graphs so that we can draw them without a calculator. Okay? We can draw them just as a line here, but we have to show all the information that's pertinent to us in which we have a point of discontinuity. So on the last graph, oops, this guy I had asymptotes. I had 2 asymptotes. This guy, I don't have an asymptote, I have a point of discontinuity. So in the first one I have asymptotes, in the second one I have only a point of discontinuity. What do you suppose happens in the third one? I have both. That's right. So what needs to happen in order for me to have both? If a rational expression remains after removing the common factors, there may be both a point of discontinuity and asymptotes. So basically, if I have a quadratic equation over a quadratic equation, and I factored it, I would get this. I have that over x plus 2, x minus 1. Okay. So where does the point of discontinuity occur then?
1, 2,
When x is equal to
negative
-2. And possibly 1, right? But it only occurs where you have the factor on the same on the top and the bottom.
Oh,
So your point of discontinuity in this case is right there, because I'm going to cancel this. All right, when I cancel it, can I graph this? The way I have it written, is it possible for me to graph it? Exactly. So what am I going to add to that, Jake? -1. And then as well as a +1. And I got that. X minus 1. Like that. X minus 1, right? That's gonna cancel and leave me with 1 plus -3. Here you go, Kelsey, this was your question earlier. Okay, what happens if my A value is a negative? Alright, so now, I'm going to graph this. So what am I going to graph? I'm going to graph 1 over x. I'm going to shift it, make my moves, and then what do I have to do in the very end? Go to where x is equal to -2 and draw my open dot.
What if it's not open line?
It has to be.
Oh, it'll be okay.
Has to be, because it has to go through that. Okay, so looking at this guy right here. A, B, C, and D. What's my A value? -3, right. What's my B value? 1. We are not going to have, we may have it once, but I'm not going to say we're not going to have it, but I think we are going to have it where we have the B value. I don't think we're going to have these graphs with B values. I hope. There might be 1. Anyway, C value in this question is what? 1. And my D value is 1. Where are my asymptotes located at? 1 and 1. So let's do this graph right here. My asymptotes are at, well, there's my asymptote. Okay. My 1 and 1 becomes 1 and what? -3 now, right? Becomes 1 and -3, and then I have to move that right 1 and down 1. So what is that point moved right 1 and down 1? 2, -4. So that's right here, and then down here somewhere, so right there. So I'm going to graph it like this. Okay? Now, my -1 becomes, excuse me, thank you. My -1 becomes +3. I need to move it right 1. Takes me to 0. Thanks for your help. And up 1 to 4. So that is right there. So I've got that so far. Okay? So I flipped it. I often like to just multiply my y values by negative, whatever that A value is. Makes it easier for me, but whatever. And then what's the last thing I have to do? I have to go to -2 on my x and draw my dot. So there is asymptotes with a point of discontinuity. Alright? So let's review now. On the first one. On this guy, I have just on this one I have asymptotes. That occurs when the numerator and denominator do not have a common factor. When there's no common factor on the numerator and denominator, I have asymptotes. When there's at least one common factor on the numerator and on the denominator, such as this, I have a point of discontinuity. When I have at least one factor that cancels, but I'm left with other factors, I have asymptotes and a point of discontinuity. And all of these things are stemming from y equals 1 over x. Alright? Okay, I will go through the 3 examples with you tomorrow. I'll put them on video, but I'll go through with you these tomorrow. I want you to work now on, and if you have questions, we'll deal with those. Okay?